What is the sheep hair shearing? So sheep hair shearing, it is a process of removal of the woolen fleece from the sheep from the body of the sheep. Next slide, please. So, what happened in India? There are two methods of sheep hair shearing. So, one is the traditional shearing by scissors, and the second one is the mechanized shearing. So, as you can see on the left, these are the scissors which the shearers use to remove the woolen fleece from the body of the sheep. And on the right hand side, it is the mechanized device which we have developed at IIT Delhi. Next slide, please. So, why do we need the mechanized device or to remove the woolen fleece? So, here I have listed some of the drawbacks of the hand shearing. So, the present method of sheep shearing in India is almost 80% of all the sheeps are being done by the scissors. And the drawback is that the staple length obtained from the sheep body is very small. So, because of that, the woolen industry in India discarded that wool which we received from those hand shearing or scissors. So there is also muscular pain, and it is also a time consuming process, and the sheep will left with some of the wool on its body also. So these are a few drawbacks of the hair shearing. Next slide, please. Please play this video. So this is
ऊन का मैं क्या करूंगा? एक बाल काटने में ये देख लो, अभी आपने जो डबल कैसी चलाई।
so this is how the hand shearing is done. So next slide. So, what is a sheep hair shearing device? It is a mechanized device, and it is also used to remove the woolen fleece from the body of the sheep. So, on the right, you can see the picture. So, we have developed the whole set in IIT itself. So, this is how we have developed the handpiece. In right of this in the right side, it is the handpiece. It is the body of the handpiece. As you can see, these barrel, outer joint, and inner joint. These are the fork and the fork yoke. Also, these are the components which we have developed by casting process. The barrel is made from the by the shell mold casting, and the fork and fork yoke and the inner and outer joint, these are made from the investment casting, and other parts these are formed by the CNC machining or milling and etc. So this consists of 32 different components. Next slide. And then we have developed the comment cutter for this. So the comment cutter, these are very critical parts, and because these reciprocate over each other, and that's why they wear a lot. So each one set of comment cutter needs to be resharpened after shearing 8 sheep, or after shearing 6 to 8 sheep. So that's why they wear a lot, and these are made up of D2 steel using VMC machining, and these are then heat treated up to an HRSC scale of 60 to 65. So these are the components of sheep hair shearing device which we have developed. First one, as you can see, is the cutter, then the handpiece, and the comb, the toggle switch, and the grinder, and the flexible shaft, and the motor. So this is how the whole assembly works. So we hang up the motor on a bar, or let's say a branch of tree, where and then we connect the flexible shaft to the drive, and at the end of at the end of the flexible shaft, we connect the handpiece. Next slide. So, what are the advantages of the mechanized device? From this, we can get the maximum staple length, and we get the uniform shearing, and it is also a fast process. So we save time for this, and this has the higher productivity. There will be a video. Please show the sorry. So this is how the mechanized device work. So we have tested our shipper sharing device at various locations. As you can see, it has been tested at Barot, Himachal Pradesh, and Bharmor, Himachal Pradesh, Palampur. Next slide. We have tested it in Bhuj and Avikanagar, Rajasthan, and Bhogpur, Rishikesh, Uttarakhand. Suraj, there will be a video on the last. Yes, please play it.
भेड़ का बाल काटने का उपकरण मिलियन भेड़ हैं जिनका पालन आ रहा है भेड़ की शेर लग जाती है देशों से आयात प्रभावित करने से ऊन की इसे आसानी से चला पर्यावरण है इसीलिए चरवाहों की आजीविका और हिमाचल प्रदेश में सफल रहा है यह मशीन भेड़ अवदेश महत्वपूर्ण कदम है धुलाई
So thank you. This has been developed till now. So further, we will be working on the 13th set of this comment cutter, and we will try to modify some of the components in this shipper sharing device. If you guys have any questions, then please ask. Thank you.
Awesome, thank you. I have one question. So I'm not sure if it was mentioned during the presentation. Yes. Is there like a guard on the shear so that you can like adjust it for possibly like different lengths? I'm not sure if there are like different types of sheep need different lengths or.
Actually, currently, what we have the thickness of the comb. Actually, like if we have the comb of thickness 4.5 mm, then it will what we can say the length of wool remaining on the body of the sheep will be 4.5 mm only. And okay. If we have the thicker comb, then we will get the. But still, we have not designed such as if we will. I mean, if we can need such type of mechanism.
Okay, thank you.
Yeah, so if no more questions, I think we'll go to next presentation by Purdue.
Sounds good. I'll just set it up. Okay, this is the bullet-driven tractor project.
Hello, we're the bullet-driven tractor team, and here we can see that our problem statement is to create an ergonomic and cost-effective bullet-driven tractor that can efficiently lift farming attachments in order to aid rural farmers with the cultivation of crops. So if we go to the next slide, we can see that there are kind of 6 different criteria developers are trying to hit. Affordability, ergonomics, integrability of attachments, the multiverse of different types of soil, durability, and the easy to use. So first, for affordability, we want to keep the cost low, which is about 10,000 to 25,000 rupees, or about 150 to 350 US dollars. Second is ergonomics. We want it to be comfortable for the rider to use in a typical 8-hour workday, while also preserving the energy of the bullock. And we want the efficiency of the lifting mechanism to lift around 30 to 35 kilograms, which is around 66 to 77 pounds of weight. Next, we want to see the easy and use in different types of soils, such as rice and wheat farming, which are the most and main common one in India and the rural areas. And we also want to be different on multiple soil types because different climates vary in different regions. Also, we want to be easy to use and easy maintenance, and we hope to have the tractor to hit a lifespan of 5 to 10 years and become a durable frame materials such as steel. And next, I'll pass on to Margang to see about the design overview.
You can go past the slide, please. Sorry. Yeah. So yeah. Hey. So I know that some of you here who've been in our previous presentations, you've already kind of seen some of the older iterations of our tractor. But this semester, one of our biggest goals was to actually start refining the various aspects of the tractor and start adding some of the finer details to actually be able to manufacture this CAD model. So you can see on the overview of our design that some of the pieces, obviously the lifting mechanism to the foot pedal, as well as the wheels, as well as the seating, the adjustable seating, it's all very similar to what we saw at the last presentation, but there have also been some additions that we made based on some feedback and some analysis that we've done on the tractor. So if you go to the next slide, Cody. I'll discuss those. So the two of the main additions that we made to the tractor are adding safety guards to the pulley system. So the feedback that we received at our previous presentations was that there are moving parts very near the area where the farmer would place his or her foot. So we would obviously want to have some protection there so that there's no cuts or so any I guess breakages in the actual mechanism itself. So we added some metal guards around the sides of the pulleys to prevent the farmer from having direct contact with them. And we've also changed our locking mechanism for our farming implement so that it can be placed in at a certain depth in the soil or be locked out at a certain depth at a certain height in the air was being transported, and we had to make this change because we made a change because we decided to have an adjustable seating on our tractor. So these are some of the main additions that we made, and then if you go to the next slide, we'll just quickly revisit how our lifting mechanism has changed. The actual mechanics of our lifting mechanism have not changed. We're still using the foot pedal, applying force and transferring that force over to the farming implement, which is going to be pivoted out of the ground. So basically just transferring the pushing force on the foot pedal to basically rotational force on the lifting mechanism through a system of pulleys. So one of the last things that we did around CAD this semester, if you go to the next slide, was we redid our stress simulations. This is because of all the changes. We made a significant amount of changes this semester to the actual frame of our tractor. We've added cutouts and holes and extra members to attach the various seating and attach the locking mechanism, to attach the lifting mechanism, all these different aspects. So we wanted to make sure that structurally there would not be any extra flaws in our frame. So we've shown you our stress simulations in the past, and those were slightly different than this because they were a different model. So this one, we just wanted to quickly make sure, and we still tested it with a 600-pound load, and overall our conclusion is that the tractor will still be able to hold up really well against even 600 pounds of force, which we believe will be unlikely that the tractor will be facing this kind of a load in its lifespan. So this kind of is the conclusion to the actual CAD portion of our project, and now we'll talk about another part of this project that we've done this semester is actually physically prototyping our design, and I'll pass on to Adrian to talk about that.
Yeah, but before we actually talk about our current design, I just want to touch on the first two prototypes that we had. So on the left, we see our initial prototype, and it was just a model that gave us a sense of how the ratio of the parts came together, and then kind of how the different components would come together so that we could begin to build from that point. In the second one, we kind of get a better idea of what we would work towards. So over here we see a scaled model of the foot and pulley system. It was 3D printed, but it had some difficulties with assembly. The pulleys didn't really work, the rope was slipping, it had a very small range of motion, so it couldn't lift very well. And so we need to create a full scale model to test it in the real conditions. So if we go to the next slide, we can see this was the third model that we had. So it was a design that's a full scale model of the foot and pulley system. And this model was created with wood studs, wall mount pulleys, wood screws, and rope. We created an Excel model to kind of get the optimum dimensions that could give us the best mechanical advantage. And by using this lever arm on the right and using the foot pedals, it could lift a pretty good ratio of weight up. So if we go on to the next slide, this is kind of where we are right now. So over here, we see a balloon and parts list. So we've highlighted some of the major components. So over there, we can see the farming implement, the seat, the frame, the wheels, etc. But some of the main components, such as the actual pulley, the foot pedal mechanism, the frame, we had to manufacture ourselves. So that's what we're working on this semester mainly. So if we go to the next slide. Over here, we see the main parts. So for the frame, we're using angle irons, and we're also using hollow steel tubes. The angle irons will be used to bolt them in place. We can see the pulley mechanism that we have, and we're using a steel rope because the durability. And then we're going to use wheels that are similar to wheelbarrow wheels, and they would be very similar to what would be found in India. And we're using a pre-manufactured seat. So all of these parts are what we're working on for the assembly. So if we go to the next slide. So we have 3 sample dimension drawings right now. It's what we're going to use when we cut the metal to get an idea of how the parts align together. And this is what we're using to organize our process for actual manufacturing. So I'm going to pass it off to Miles now for the next slide.
All right, so we are currently assembling our tractor at one of the on-campus EPICS labs here at Purdue. These pictures are just showing the main machinery that we're using at the lab to construct the prototype. So on the left is just a drill press, which we're going to use to drill the holes so that we can join the pieces together. And on the right is a cutoff saw, which we use to cut the steel brackets into angle irons, which can be seen on the next slide. So next slide, please. Okay. So we were informed that the final tractor would most likely be welded. However, in this prototype, we're not welding it. This is just due to a few reasons, one being reusability. So welding these pieces together makes the reusability of these parts much harder for future projects. And then not welding the pieces would also allow us to make modifications easier, which could be pretty important when we're testing. And then lastly, since we've already made frame structural integrity calculations in our stress test, as you saw earlier, we don't think it's a major part of our testing. So in the picture on the top is all the cut metal and shows the shape of the frame. And the bottom picture shows how we are attaching the pieces together. And then, so at first we connected our steel pieces with just the angle irons, which can be seen on the bottom right. But we found that they weren't strong enough to hold the shape of the tractor since the angle irons were just made of aluminum and it was not nearly as strong as the steel that we used to construct the frame with. But if you look at the bottom left picture, we added a bracket on top, which pretty much tremendously increased the strength of these joints. So in the next slide, I'll talk about how we plan to test the tractor. So we decided to break up our test plan into 4 different stages so that we can test each part of our design step by step. The first being the component tests, where we're testing the structural integrity of the frame with the added weights and the functionality of our lifting mechanism. The second test, the static or stationary test, will test the seating ergonomics and the seating adjustment system. Third is the full assembly test, when all the major components to test movement will be added to the tractor. Here we're testing for the overall smooth movement of the tractor and how all the components act together. Lastly, the farm test is where we will test how the hitching mechanism functions and see that the tractor's structural integrity is not negatively impacted by rough ground dynamics. This is something that we're planning on starting at the beginning of next semester. And then, so now I'll finish up by talking about our upcoming goals in the next slide. So as far as our next steps, we're going to finish manufacturing our steel prototype design, which will require adding the seating, the farming implements, and the locking mechanism. We also want to make a schedule for our testing through next semester using our test plan. And then lastly, we want to refine our CAD model based on our findings about what went well or poorly during our testing. This is pretty much like an ongoing task for us, though. We've been updating this CAD model throughout the semester whenever we'd find like any weaknesses. So that's all we have. Is there any questions?
Yeah, I want to congratulate for the hardware components already started building. Thank you for that. And just a curiosity, so far, how much you spent already on the components and some machining, which you might have done outside or you paid for?
Yeah, so actually, our machining doesn't actually cost anything for us because we can actually just do it at our EPICS lab, so that part is free. But on the components itself, I think we're at about $800. That's because we had to buy a seat and we had to buy weights to be able to test our lifting mechanism. So these are some of the things that are really like ramping up the costs. But we definitely believe that by the time we get to a final prototype, we can cut down a lot of the most expensive aspects of it and really bring the price of the tractor down.
Okay. The second relevant question is, does the university pay for such costs for every project, or how does it work, the cost part?
Yeah, so we actually have grants that we apply to. We have every semester we can apply to. I think it's up to a $1,500 grant, and for this semester that was enough for us to be able to pay for the prototyping.
Good. Thank you. Continue the good work.
Yeah, thank you.
One thing I think in the cardboard cutout, you have cut out a cow instead of a bull.
Yeah, that's actually that was like a really early prototype, and we just kind of wanted to see how everything would put together. So yeah, I wouldn't be surprised if that's is. Thank you.
All right, nice job, guys. Any other questions for the bullet-driven tractor team? If not, awesome. I will send it back to you, Suraj.
Yeah, so I'll be giving the final presentation. Yeah, so this is a presentation about the groundwater level measuring device developed by Ruta IIT Delhi. So just a bit of a background. Groundwater, as you know, it's the water found beneath the Earth's surface, so it varies based on the location. And in some parts, you can find the water like usable groundwater at a lower depth, and sometimes it will be very high here. So then what water table, some definitions I'll be going through. What is a water table? It is the depth at which the groundwater is available at a particular location. And as you can see in this figure, it varies based on the geographic location. So for this water table, there are some things known as monitoring well, and these are narrow tube wells which are installed at various locations so that the water depth is can be measured easily, and it can be the data can be saved so that any organization or the government planning for the city, they can know at what location what is the water available, and how it can be utilized and how it can be planned further. So this on the left hand side you can see a monitoring well. This is a narrow tube well inside which device is inserted so that he can find out what is the water level at that area. So India has a central groundwater board which does these things. It keeps a database of what is a water table at different locations, and additionally some NGOs and different organizations, they also monitor and survey these water tables so as to create awareness or any other policy planning and such. So this was the earlier device used by an NGO in Rajasthan. So they had this plastic spool with this cable and a rod, and they had an ad hoc arrangement to fix this with a circuit, so that whenever this pipe comes in contact with the water, this circuit gets completed, and there will be an alarm. So by this, the one who is measuring, so he'll get to know that the water is at this level. So he'll be measuring the length of this wire. So this setup was prone to false readings and false alarms. And since this was not properly designed, the tube used to get stuck in between, and there used to be difficulty in taking the measurements. So this is the modified device which was redesigned by Rutag IT Delhi. And as you can see, this is a pretty robust design with a box for the circuitry and battery. Sorry, and the whole probe was redesigned with a plumb bob design, where it was built out of rust-proof material, the stainless steel, and the mass was again redistributed so that whenever it is inserted into the tube well, it goes without any deflections. So the vertical stability is maintained here, and the user can get an accurate reading without any false alarm. So this whole spool comes with a marked cable. So whenever this touches the water and the buzzer beeps, the user can just check the spool and there'll be the marking saying this is the depth at which the water is found. So you can see in this video how it is done. It is inserted
ये
in,
देखते जाना
and now here you can hear the beep. This means it has touched the
धीरे धीरे डालना
surface of the water. So here you can find out the marking and he'll be recording it for future use. This was field tested in Chirawa, Rajasthan.
चालू कर
So building on this, there was a startup based out of IIT Delhi known as AquaSense. So they have like come up with a contactless sonar based ultrasound based device. So just you place it on top of the well and it shows you the reading, like at what depth the water is available, and this is an IoT device, so it can be connected to internet and stuff. And right now this is under process. A mobile app is being developed as well, so that the user can either say, or whenever he's taking a reading, he can just speak on his mobile app what is the depth at which, and it records it along with the location data as well. So this work is in progress. Thank you. If you have any questions, please.
That is super cool. I like that a lot. One thing that I noticed immediately was last summer I worked for a water company, and whenever we wanted to determine the level that a well was at, we used a device that was like the exact same thing. It was so similar. That just reminded me of that. So sorry.
Okay. So where was this? In which place? Like which place were you working on?
Oh, I was working for a water company in and around Purdue.
Okay.
Yeah, sorry to distract. That's really cool. When do you think the mobile app will be ready for like testing?
It's in development. Like a student is working on it. I think maybe coming 3-4 months we should be able to have a prototype or something, first version at least.
Wow, that's pretty quick. Nice. I like this a lot.
Yeah, actually, just to add here, the mobile app we are developing in connection with that the other version, the wired version, because the contactless version is almost like 15 times more expensive than the wired version. And the contactless, that startup, they have a facility to upload on the internet or the cloud. Now, what we are doing with this mobile app is the word version, the person who was testing it, he can speak with the mobile app and the data will be uploaded to the cloud. So it is this word version cost about 10,000 rupees, Indian rupees, and the mobile app may not cost anything if it is provided by the government agencies. Otherwise, maybe very little less. So compared to the IoT enable AquaSense, so it will be the economic version of the facility. Yeah. So 3 months we should be able to test it.
Yeah. Any more questions or?
I had one question. So the contactless version, obviously, it looks really cool. Is that something that Rutag is working on with the startup, or is that just a startup by itself?
No, it's by itself. Like they've grown out of Rootag, so
Oh, okay.
it's a different company. Like they built it on our model, and now they're on independent.
Yeah, just to add, the professor who was helping us developing the Word version, so they realized that they can have this IoT-enabled contactless version. So they have then evolved to a new company, and now they are on their own. Yeah.
Oh, thank you. Really, really interesting project.
Thank you.
Yeah, thank you. So I think we are done with all the presentations.
Yeah. So from my side, thanks. I just wanted to have one or two quick discussion regarding what Cody has presented at the beginning about that IEEE projects, undergraduate projects, and I think in our last meeting we have been discussing, and I was agreeing to the fact that maybe I can talk to my chair of my department to see if a student in the final year from mechanical IIT Delhi could pair up with some members from Purdue or some other university for this IEEE part. So I'd like to know more about it actually, and so that I can take a concrete step towards that directions in future months to come.
Okay, are you saying you want to know more about the electrical side of the
No,
project, or?
no,
So,
how yeah, Bill, go ahead. How does this arrangement would work? I mean, that's I want.
So these are relationships. So this isn't this is something that we're creating. Okay.
Okay. Okay.
And what Cody's done, Cody's been working on the team now for 3 years, or this will be his 3rd year. We hope in year 4, yeah. For him, so the students can take it for different credits. He needs to do a final year project next year.
Okay. Okay.
And he would like to stay on the team. So instead of him having 2 different projects, we said if we could add complexity to what he's doing to meet the electrical engineering final year criteria, that he could work with that. And what we've done is, because his project's working with IIT Turpity, is that they're going to look for some students, and we are negotiating there what that would look like.
Okay.
I would be more than happy. So I'm a mechanical engineering graduate from Purdue. And they have been one of the more difficult schools to work with in EPICS. So like my own people, but I honestly, what I'll do, and I'll probably loop Arvin Rahmanian, but to see if I could get some final year students in mechanical to do a little pilot project. It could be mechanical. It could also be agricultural engineering. For us, has mechanical subspecialty.
Okay.
And what I'm thinking of it is to identify something where we could work with your students, not adding on to Cody's. Well, because honestly, I'm not quite sure if I think of the criteria for mechanical students, the direction we're going with the projects. At this point, we don't have a mechanical purpose. And if we were doing that just with Purdue and IIT Delhi, to add a 3rd university adds, right? I think each degree of freedom, I think it's exponential growth of complexity. So let me get back to you within the week, at least exploring if we can do that. And I'll tell them that there's interest. And I think I'll loop I'll loop the I think the heads of the department and some of the key
No problem.
people in that. But it's, I would like to tell you there's no politics at Purdue, but that would be a total lie.
Okay. Okay.
But with that, and honestly, things have been a little chaotic. But we are that okay. That I'll explore. So if you can, if you could approach to say, you know what, there's interest, but with the caveat that we still have to find the students, and this is something I would like to build on. I mean, honestly, in my when we've talked, and I think Cody has said that we've talked about this, that in my dream, I would love to have these where students could come in, they could have this final year project. The kinds of things that you work on are of interest to us. We have struggled with how to get our students engaged in India, and part of it's been hard to do study abroads, and it's expensive, you know, to fly. And this opportunity to do this virtual is to give some of the students maybe that may not travel, but this international experience. And I'm excited about, you know, students having this multinational design experience, because that's the world that everybody lives in, and to have the kind of quality there. So your interest is giving me leverage. I think, like you, with the pandemic and the ever-changing scenario, it's we're all
Yeah. Yeah.
you know, scrambling.
Yeah,
And I have to tell you that you all have been, I think, a gift to us, that we've talked, that not only have we made progress, but we've built some more relationships.
Thank you.
And it's added to the richness of the experience. And it means a lot. But I will that I'll work on that a little bit more. So I've got two opportunities, and I think we could have somebody.
Yeah.
Would your students be doing it in one semester or two?
One semester.
Okay.
Well, actually, it's a 2 semester, but it's an optional. The students can finish the first semester with less credits. If they want to continue in the next semester, they can, or they drop. I mean, drop means they take courses, not the projects.
Yeah.
The first semester is about 4 credits, which is about 8 hours in a week, kind of effort. And the second semester is about 7 credits, which is about 14 hours of effort in a week. Yeah. So I'm sure if we can find an interesting problems to work with, students may continue both the semester, and that future has to tell how to proceed.
Okay.
But find out interesting projects to work with, actually. Okay.
Okay.
So thanks everybody for this, and I just thought to share this thing while I was listening to all of you. Even though at RUTAC we call it WeLD R, means we learn through discussion for RUTAC, but today I thought we should insert an E in between to make it really the word called WeLD R, and WeLD, and WeLD would mean we learn through discussion between EPICS and RUTAC. Okay, so I hope you would like this. So from next time onwards, we may say, no, this is our 3rd WeLD. So next one will be the 4th WeLD, right? And WeLD means we are welding between ourselves, the community, students, and the faculty. Okay, so with this, I think we can propose our next one, and I'm sure we are enjoying. At least I am enjoying. So if you wanted to keep it live, so let's plan for the next one, maybe June, July, depending on your holidays or semesters.
Well, I was going to say, so our students will leave campus in May.
May.
So when we would pick this up, it would probably be September.
September. Okay.
Yeah.
Okay. So tentatively we keep September and
Yep.
with a lot of time.
Yeah. And so we can communicate. Cody will, Cody and we can loop Bree or whoever in too.
Okay.
But Dr. Saha, if you communicate with Cody and myself, that we can help.
Sure. So I think we need not fix the dates now in that case, as I understand. So September, Suraj would remember, and I hope he will not graduate by that time. Yeah.
Absolutely. Absolutely.
And and in between, what I do is Cody has to help me to get that information about the Tirupati experiments so that I can take it forward with my Delhi clusters. And with Bill, I will probably take this forward about our final year graduate. Just before we leave the program today, I just wanted to mention to Bill, I got to know one professor from Purdue. I don't know whether he's from mechanical, Professor Voyles, Voyales. Probably he works in the area of robotics, actually, you know. And I just came into contact through him. It seems Purdue has a MOU with our one government-sponsored activity called SERB, Science and Engineering Research Board. And they are hiring students, PhD students, you know, from India full-time for Purdue, or those who are engaged in India, they can spend time in Purdue.
What's the faculty member?
Just
it was,
a sec.
It was V.
1 minute. I'll just do.
Okay. Or if you just forward that.
Yeah, I'll do that. Actually, while I wrote him, I mentioned that we are already connected to Purdue with this EPICS program. So already I mentioned your name to him, but now maybe I will mention his name to you so that internally you can
I'd be happy to.
Yeah.
I'd be happy to reach out.
Okay, so guys, enjoy your oncoming holidays, and we'll keep remembering these sessions, and have a nice day. Bye.
Awesome. Thank you guys so much. Have a great evening.
Yeah.
Thank you. Have a
Thank
nice
you.
day. Have a
Have a
good
nice
rest of your day.
Cody, team, are you guys good, or do you need anything from us?
Professor Oakes, I'd love to talk with you just for a minute if you have a moment.
Yeah.
Then let's hop back up on the general channel.
Sounds good. See you there.
Okay.